Hello and welcome back. My name is Karthike and today we will code supervised learning. Before that, if you're new to the channel, please subscribe and ring the bell icon. And if you're a regular subscriber, comment, like, and interact with the content because that helps YouTube algorithm, and that helps me. And if you like the content, just tell me what you like, and if you want something, just tell me in the comments. I will try to provide you. So we will code supervised learning and I will use a big mar data set. For that I will tell you everything while we code through it. I will take the reference of my notes which I have made throughout the years, but yes, so that I can be 100% sure what information I'm providing you is correct. So let's start. We will start by importing necessary libraries, and don't worry, I will tell you what exactly every library does while I am importing it. And let's start with it. Let's first import numpy library. Why numpy library is useful, you ask? Numpy library is actually a library which helps us to do maths with our data. You can remember this as in very generic terms as math library, which is very generic to say. It does complicated things like complicated maths. So but for remembrance sake, just remember as it does complicated maths. Pandas, let's import pandas. What pandas do? Pandas Panda is a library which help us to interact and work with our data. The data which we get is in very raw form. So pandas help us to categorize in row and columns and help us to make a data frame out of it. Okay, now let's import. We will do some maths on it. We will find inner quartile range. I will tell what is quartile range and inner quartile range. So we will need a math library, and because we are doing statistics, so we will use Sqrt, which is square root. So we will import math from maths import Sqrt. So why I'm writing as numpy? Because when we will why I'm writing np, pd and sqrt. So when we work with data, it is very repetitive to write numpy pandas again and again. So if we say import numpy as np, so we don't have to write whole numpy, where we have to only write np or pd to work with it. And from maths library we are importing square root, which is like you go to maths and import square root functionality from it. So this does that. We will use a linear model. So from sklearn is again a library dot pre-processing. Okay, let's pre-processing import label encoder. So what is sklearn? So sklearn is a built-in library which is also known as scikit-learn library. And a label encoder, what a label encoder does, it actually encodes the data, because when we get data, we get in human readable form, which is not useful for machines, because machine uses 0-1 binary. So what label encoder does, there are some missing data. So label encoder in very generic terms is used to label and encode that data which is not present. If something is not present, it will import it will say 0 there, and if something is there, it will actually make a matrix, 2x2 matrix, and let's say here it is abcd and here it is abcd. So if a is not present there, so it will import a there, 0 there, and if then it will check, okay, b is there. So if b is there, then it will say, okay, 1, b is there. So it fills like that, and it helps to normalize our data, so that and standardize our data, so that no data in our this model is anything which can jeopardize our model. Let's put it that way. Okay, from sklearn now we will use linear regression. So we will say from sklearn, again we will use scikit-learn, L-E-A-R-N, linear model, L-I-N-E-A-R, I guess, linear model, import linear regression. So okay, so from sklearn, linear model, import linear regression. Again, linear model here is your library from which we are importing linear regression functionality. Okay, let's see or Google something to clarify this. Okay, I was thinking sk dot linear model. Okay, let's go and let's open Google. Let's say sklearn linear model. Okay, sklearn linear model. Let's say image. Okay, so this is actually linear regression in very basic terms. So these blue dots are our data points, and this is our linear line. Linear is basically what we, if something is say, we say that it is a linear path. So this line is actually our let's say linear regression model. The goodness of it, which we will talk about, which is known as Rsquare method, tells us how good data is. If the data is present on the line, it is very good for our model. If data is close to our line, like this, it is like, the more it is close to our line, the good it is. The more far it is, it's not that useful of a data for us. So this is our linear regression Python for scikit-learn. Let's now see sklearn label in code. Yeah. Okay. See, we have x and y, x1 and x2, and this is y. So we actually say these values are given the code of 0, and this value is given the code of 1, and this value is given the code of 2. So whenever there is this value present, we will get 0. Whenever this value, which is our here, we will get 1, and whenever this value is present, we will get 2. So this is how label encoder work. It helps to encode our data so that we can use our model in very efficient way. Okay, so we have done this. Now let's import some matrix. Let's say import our Rsquare thing. So again, from sklearn only dot matrix import Rsquare score and mean SQUARET. Error. So what is mean squared and R-score? So as I said, Rsquare is goodness of it, how good data is, and mean square is a statistical term which help us to find mean of mean of our data, mean square of our data. So in maths, it looks like this. This is like average or square derivation of a truth. See, this is what mean squared error does, and it actually provides us mean square of our value and mean square error of our value. In very simple terms, it helps us to minimize our errors. And let's go for R square error or score. Okay, so here it is. So what Rsquare does, it actually tells how good our model is. So these are the libraries which we will use and we're gonna import. So we will import these libraries in our Jupyter notebook, and I hope if everything is right, this will import it. So it is importing our library. Yeah, it is importing. It will take time, and if you have a fast machine, maybe it does quickly there. Okay, we got some error from sklearn. Okay, dot pre-processing. sklearn dot if okay mod. I think it is right from sklearn linear regression. Okay, what is the error there? sklearn linear dot model linear regression. I think it is right. Import what we have to import sklearn. So we were getting the scikit-learn error because we forgot to install the scikit-learn library. So this is the command to install the scikit-learn library in your Jupyter. So please make sure that you do that before like running your libraries, because it will show error as it's shown as shown in my this video. But if you have installed this like scikit-learn, it will work like a charm. Okay, now let's go and import our data. Let's make a variable named train. We will use pd to work with our data. We have to read from a CSV file, which is comma separated files are always have an extension of CSV is read underscore CSV. We will go and the name of our the name of our data set is train big, okay, in quotation big mart underscore train dot csv, if I'm not wrong. Yeah, let's import it. Okay, now our data set is imported without any error. To see some elements from that data set, let's say train dot head, let's say 10. This will give our top 10 values which are present on, like 10 rows and columns which are present in our data set. So yeah, this is our bigmart train.csv data, where we have item identifier, item weight, item fat content, item visibility, item type, item MRP, outlet identifier, outlet establishment year, outlet size, outlet location type, outlet type, and item outlet sale. Okay, now we have imported our data. We have seen what is in our data, and if you want to, let's say, see all of the data, not top 10 only, just go and say train and run it. This will give you all the things which are, it is showing that we have 8,523 rows and 12 columns. So yeah, and as you can see, we have 8,522 rows and 12 columns. So this is our whole data set. Now let's check the shape of our data. To check the shape of our data, let's go and say shape. Okay, I think, yeah, again this will give you the number of rows and columns which are provided here. This is like if you want to find it out and you are using some ID which does not give you this, so this command is for that. Let's check if there is any null value. What are null value? Like this nan, this value is known as null value nan. What is these values? These are the values where no data is present. So this can give discrepancy in our data set. So we have to figure it out. We have to find a way where we can remove or somehow do something to prevent that discrepancy which comes from nan. So the one way to do is to say strain dot is nan is null, which is like if there is null, dot sum, make a sum of that, then it will give us how many nan values are present. So as you can see, we have 1463 in our item weights. We have null value 1463 in our item weight column, and we have 2410 in our outlet size, which is this. So we have to somehow fix it. Okay, let's do something. So we have to work with item weight. So to get the column of item weight which we have in our train, say train, and now we have to find that column. We have to get that column. So train dot item underscore weight. Okay, item underscore weight. And what we have to do is we have to work something, or let's do something like this. Item fat content. Let's first go and see what is item and fat content, and is there any unique value. Content and dot UNIQUE, if I'm right. This will give the number of unique value which in item underscore fat dot content. Let's okay, before doing that, it will be a string value. So okay, so as you can see, item fat content have 1 2 3 4 5 values in its array, which is low fat, regular, then this is also low fat, LV, and regular, and this has data type of object, and these are some unique value. What we have to find is, let's say we have to find some unique value in outlet establishment here, and I will tell you why we are doing it. Okay, we are actually trying to find unique value and non-values, and we are trying to find a relationship, or we are trying to find something with which we can use to work with our data set. Outlet establishment here, let's copy it for like spelling sake. Okay. Dot, let's say unique value. Okay, so there are these unique values in item establishment here. Okay, can we also find something? MRP will be different, it's not unique type. Item type is also different. Visibility, I don't think we can use visibility. Location type, we can use outlet location type or outlet type, we can use that. Or if somehow we get like item like outlet age, let's say if you want to have an outlet age, how old that outlet is. So here we are making a new column which is outlet, yeah, outlet age underscore age. So outlet age, how we can find outlet age? So we have this outlet establishment here. Okay, so what we can do is we can subtract year which we are in to this outlet establishment here, and it should give us outlet age if I am not wrong. Yeah, so let's say I'm coding this in 2022 minus let's say we are using, okay, now we have to say stabilized train, we are using train and we will use outlet establishment here. So copy this and yeah, so this will give us a new column which is outlet age with the amount of year they have been operating. So if we want to see, then we can go and say train data out, okay, age. Okay, now you can see that we have the amount of year they have been operating. And if you want to see in data, then you say train dot head okay. So now if you can see, we will hopefully have our outlet age here 23, 13, 23, 24, 35, and this is our establishment here. Okay, we have done that. So now outlet size, what is outlet size? Okay, so we have some different outlet size. Let's take out unique value, because if there are unique values, NaN and NaN are not unique values, which will inherently mean that we will not get NaN, we will get the unique values which are present there. So if we say train and we choose outlet size, dot QUE, then it should guess. Okay, we have medium, NaN, high and small. Okay, we want to use medium, high and small. So what we can do is we can first see what our training model describes, and then we will work on something else. Train.describe. We're just like trying to come up with some solution. Okay, so this is mean, standard, minimum. This is actually, see, these are actually statistical value which are associated with them. So this is giving us our mean value, this is giving us our standard deviation, this is giving our minimum value, this is giving our 25 quartile range, 50, 75 and max. So what is standard deviation? Deviation is actually the amount of let's say difference, the amount of difference which we get, and how what is the formula of standard deviation. So in statistics, the formula of our standard deviation, if I'm not wrong, is sigma frequency minus amplitude upon sigma frequency whole square minus sigma of f minus a square upon sigma of f square divided by, I think, a x whole square minus x square under root and y whole square minus y square under root. If I'm not wrong, this should be the formula of our standard deviation, or if I'm wrong, let's see, standard deviation formula. Yeah, like x, if okay, here it is represented at x minus x dash way, but yeah. See, x whole square and x square upon n minus 1. So yeah, like so we calculate standard deviation by this formula. I think I was off. I was like simple. Yeah. So this is the formula of standard deviation. If you wanted to know, there's that. And yeah, so this is that mean, standard deviation, and minimum. This is the statistical value which represent our this value of statistics which are associated with that particular column or row. Okay, let's now explore our data more, and let's see if we can go and say fat content. We have not used fat content, so item learning train underscore fat content of okay, item fat content. Item fat content. Okay, item fat content dot what we want to check. Let's check unique value. If let's check what's harm in checking anything. Okay, low fat regular, we have checked this. So what if we want to count the values of in this? What we have to count? Value of this value dot count, I guess. Value dot count or counts. Yeah. So we have like low fat 5089, regular 2889, LP is 316, REG is 117, and low fat is 112. Okay, so we got values from this. Now we can go, and what we can do is outlet size. Can we do something with outlet size? If we take let's see, train outlet underscore size. Okay, dot what if we take row only? So row are represented by 0 and columns are represented by 1. So we have outlet size. Where is our outlet size? Outlet size. So yeah, we have to take row, no? So if I'm not wrong, row is represented by 0 and columns are represented by 1. So we will say we have to take row outlet size dot I think mode. Mode, no, there's not mode. What it is? Mode. Let's check for row. Okay, there's some error. Okay, we spell something outlet. Capital S. And mode. Okay, so we got medium. Now what I'm doing is EDA, which is Exploratory Data Analysis. So we are just exploring our data right now, and yeah, we got our outlet size. This is medium. See that row from outlet size, we got this row. Okay, let's say outlet size dot we have to somehow fill that any n value, which is null value present in outlet size, which is this value. We have to fill this value. So what we can do, we can make a column. We can need a column. No. We can make a column. We are making a column train, and we can make a column like out underscore size. So just because you don't get confused, this is in small, this is in capital O size. So this is actually a new column, this is the old column. So what I am doing here, I am making a new column, and the variable of the head or like column heading is outlet size, and I will say that like outlet size is train, and we have to take data from this outlet size. So we will say train dot outlet size, outlet size. Okay, fill any, if I'm right, or fill any is fill any in outlet size. Fill any in outlet size out. So what I'm doing is I'm saying take a outlet size column which is present in train and fill the any value with some value of that outlet size column. Okay, so method is an object. There is some problem. Okay, we are using that row and column thing, so we have to say that mode. Okay, and we are operating on rows. Okay, there is something off. Fill in. Okay, we are not seeing this. Yeah, so the problem was there that we said fill NA in outlet size. Okay, so it took the the machine know that we are filling NA in outlet size, but it does not know from where, like in which context you are saying that. And dot mode dot 0 is for that we are operating on rows. So there's that. So if you want to see, then train dot outlet let's go size. Okay, there is some error. What? Okay, it was operated, but it never. Oh, yeah. What if I say train? Yeah. So then we have our outlet size here. Now here, see the NA value got the NA value which was there is not error. So let's see the NA value here is filled with medium. So what fill NA does is take an average. So let's say see medium, it goes for medium here. High, see high, medium, it goes for medium. So it takes an average value. So yeah, you can see this that our NN values got fixed. Now what we can do or explore in our data set, we have not worked with item or item weights. So let's go for item weight, but we will continue this video in another video, so please watch that video and subscribe and like and comment. And if you like, if what you like, what you didn't like, just tell me in comments. It helps YouTube algorithm, to be very honest. If you don't like it, you can tell me that. If you love it, you can tell me that. And if you want to subscribe and do that all kind of things with which can help me to grow, please do. And if you don't want to, just be happy, and you don't have to. So please see you in the next video.